Welcome back. Let's do question 2C. Point A and B in the first quadrant are points on the quadrilateral ABCD. Equation of line DC is y is equal to -1/3 x minus 1. DC forms an angle theta with the x-axis as indicated. Determine the equation of line AD if AD is perpendicular to DC. We have the gradient of DC from the equation. This is y is equal to mx plus c. So it means the gradient of DC is equal to -1/3 from the coefficient of x there. And then if the lines are perpendicular to each other, then their gradients are negative reciprocals of each other. So it means therefore the gradient of AD should be +3. The negative reciprocal of -1/3 is 3. Or the gradient of AD times the gradient of DC must give us -1. We have the gradient of DC, so the gradient of AD times -1/3 should be equal to -1. We can divide both sides by -1/3, which is like multiplying by -3. So gradient of AD is equal to -1 times -3/1, or t times. Dividing by a fraction, t times, then you get to +3. Or if you can identify the negative reciprocal without doing all this, it's still okay. We have the gradient of AD. Now we can find the equation AD. We also have point A there on AD. So we start with y is equal to mx plus c. Now y is 10 is equal to -3 plus c. Then becomes 10 is equal to -9 plus c. And then we have 19 is equal to c. Therefore, y is equal to 3x plus 19. The other thing could have said y minus y1 is equal to mx minus x1. If you substitute y minus 10 is equal to the gradient, which is 3, gradient of AD, and then x minus -3, which is +3. Y minus 10 is equal to 3x plus 9. And then y is equal to 3x, and then 10 plus 9 is 19. That's the equation of AD.